Hi guys, my name is Benedict and I'll be presenting problem 115 and 116. So to start off with problem 115, it wants I'm required to find the range and the height. The height is the horizontal and the range is the, of course, the range and the maximum. So find the range and the maximum of height basically. The projectile is fired at an angle of 45 degrees to the horizontal with an initial speed of 100 feet per second. So down here I have a range, which is the R, and the height, which is the H, and G is, stands for 32.2 feet per second and 9.8 meters per second. So you can have second to the power 2. To move on, we were provided with the range formula and, of course, the height formula. And then to find the range, we just have to use the formula first and plug in the numbers. Where did the 45 degree come from? Well, the 45 degree came from because, it was given to us. It was presented as the projectile is fired at an angle of 45 degrees. So I assume, the range will be, theta equals to 45 degrees, and then the formula, basically. So I got the number. So we have 100, which was the 100 feet per second. So we have 100 feet per second, to the power 2 times sine 2, the 2 times, we put the 2 here, times 45 degrees, which is feet to the power 2 per, second to the power 2, over feet, time feet divided by s to the power 2. So the feet and the second, s, it stands for the second. We did that, and then to solve the problem, it gave us 10 to the power 4 over 32.2 feet. How did I get the 10? Well, how I got the 10 is that to get 100, you would need 10 times 10. That would give you 100. So with this 2 right here, I just figured, maybe if you just, I don't know, I just came up with 10. I don't know, for some weird reasons. That just gave me 10. I had a 2 here and a 100 here. So I was like, you divide that. So I got 10. And then the way I got the 4 is also... So yeah, 10 to the power 4. 2 times 2 gave me 4. And then I did the math. 10 to the power 4 over 32.2 feet. Is congruent to 310.55 feet. That's our range. We found the range. Now we have to find also the height, the maximum of the height. So we go back to a formula. We have the formula, and then we have the numbers. And then we also know that an angle is 45 degrees, and we also know that the speed is 100 feet per second. So we do the same exact method. We just have to, again, plug in the numbers: 100 feet per second, times 2, and then sine 45 degrees to the power 2. And then we have down here 2 times 32.2 feet over, seconds to the second. Again, over seconds to the power 2. And then if you solve for that, you get again 10 to the power 4 times square root of 2 over 2 to the power 2. Where did I get the square root of 2 to the power 2? Sine 45 degree on the unit circle. Sine 45 degrees basically is square root of 2 to the power 2. Just check on the unit circle and you'll see what I mean. And then you divide that by 2 times 32.2. And on this side, you have feet to the power 2 over s to the power 2. Divide by feet over s to the power 2. And you could just easily cancel this out. Since you only have feet here and feet to the power 2 here, you'll only know that you have only 1 feet left, and s to the power 2 and s to the other power 2 cancels out. So that's why we had only feet left here. When we solve for that, we got 10 to the power 4, 2 over 4. How did I get 2 over 4? 2 times 2 is 4, and the square root cancels out, so you only have 2 over 4. Divide by, we bring this number at the bottom, we bring it back down here at the bottom, and then you still have 2 times 32.2 and fit. So 10 to the power 4 times 2 over 4, divide by 2 times 32 fit. You'll get 10 over 4 divide by 432 fit. And then when you do the math, it will give you your height. Your height is equals to 77.63 feet. So that was problem 115. They wanted us to find the maximum of the range and the maximum of the height, which we have, easily found. Thank you. Alright guys, so I'm back to solve another problem, 116. If you recall, I just solved 115 on the first part. So 115 asks, the projectile is fired at an angle of 30 degrees to the horizontal with an initial speed of 150 meters per second. The first one, the first part that I solved, it was, the projectile was fired at an angle of 45 degrees and the speed was 150. But on this one, the angle is 30 degrees and, the speed is 150 meters. That one was 100 feet per second, and this one is 150 meters per second. So the formulas does not change. The formulas don't change. It's just feet and meters is the only thing that changes. So again, we have our range formula, which is down there, and then we just plug in. So we have 150 meters, per second. And we have the, of course, it all multiplies by 2. And then times sine, which is 2, the 2 that we got here, times 30 degrees, which is our angle. And if you recall, the G is also 9.8 meters per second. And I took the problem down as a genius. And then I got 150, squared, times sine to 60 degrees. How did I get the 60 degrees? 2 times 30 equals 60 over 9.8 meters per squared. Meter squared per over second, squared, which will equal to 150. I'll still have this the same way. 150, to the power 2. And square root of 3 over 2. How did I get the square root of 3 over 2? Sine 60 degree equals square root of 3 over 2 on the unit circle over 9.8 meter. And if you just solve for that, you'll get 1,988.32 meters. That is our range, our maximum range for the meter is 1,988.32 meters. The range is always the easiest one to solve, and that's what we did. It was a simple problem. And then we move on to the horizontal, which is our height. We still have the same formula. We just have to plug in the numbers, which I did, and same process, 150 meter over meter per second squared, and then sine of 30 degrees square, and then 2 we multiply the 2 times 9.8 meter per second squared. And if you solve for that, you'll go down with, excuse me, my fault, you have 150 squared, sine of 30 degrees 1 over 2, squared, meter per second squared, meter squared per second squared, I'm sorry. And then if you have that, sorry, my camera is shaking a little bit. It's because I'm recording this by myself. You still have 2 times 9.8 feet per second squared. Then the feet comes in, but I wouldn't worry much about it because it's really not that much of a big deal. You can convert feet, meters. And when you solve the problem, yeah, you still have 150 to the power 2. How I got 1 over 4? It's easy. We remember how we have 1 over 2, times 2. It will equal to 1 over 4. And then you still divide that by 2 times 9.8. If you solve for the whole problem, your height will equal to 286.98 meters. So we again found the range and the height in meters. And then if you recall in our first problem, we found the maximum of the range and the height in feet. And we just have to find the maximum of the range and the height in meters. Thank you. This is Benedict Mosimisa. Bye.